perfect. Thank you so much. Yes, so today's session, as I said, is TechCheck. It's a format where we introduce technical stuff in a tangible and hopefully entertaining way to you. Today it's about coding and software development. And yeah, as you all know, this is part of the Online Learning Lab. What is the Online Learning Lab? It's a series of online workshops that we do here at Pioneers. Next slide, please, Michael. And this is already the 8th session. And our goal is to maintain exchange in the innovation ecosystem, to learn new things, also in times where a lot of people are in home office, and also technical things, innovation topics. And yes, if you have already signed up, as most of you, I guess, have, then you will receive the slides afterwards. We also publish the recordings from time to time on our YouTube channel. If you wish to have the slides and you haven't signed up, always feel free to shoot me an email. And yes, some things about the Zoom functionalities, maybe most of you have already been in a session with us before, I guess. But if you're new to Zoom, you can use the reaction buttons to approve with something we say. You can also disapprove or ask critical questions, hopefully in the chat. We really want to make this interactive. So we also have exercises towards the end where we invite you to also speak up and answer your questions and solve our difficult or semi-difficult coding exercises. Yeah, but first of all, maybe we want to quickly introduce ourselves. Can you go to the next slide, Michael? One more. Yes, thank you. So this guy here is my colleague, Michael, and he's not only an innovation consultant, but also a developer. So Michael.
Yeah, I'll quickly introduce myself. Hello, everyone. I'm super excited for this session today. My name is Michael, so we're Michael and Michael, but my name is actually Michi and his name is Micha, so that's how we can differentiate ourselves. I've studied at the VU Vienna, that both bachelor and masters, and have always been interested in entrepreneurship. And during my bachelor's and master's, already worked in sales and marketing for several startups, and have also always been interested in the tech side of the business. So I decided also last year to go more into that side, and Pioneers allowed me also to improve my knowledge in coding. So I did a full stack web development training over several months to learn coding from the beginning, and now also applying already the knowledge that I gained in the last months on my own projects, and super happy to share my knowledge today with you and give you some more insights, especially for beginners that have never learned coding so far, but also for, I guess, some people that have maybe heard a little bit about buzzwords like HTML and have maybe heard about that, but are not really sure what coding is all about. So happy to give share some insights with you today and make it, as the other Michael, Micha said, as interactive and practical as possible. So you cannot expect too much theory from us today, because that's not so interesting, at least for us. So
cool. So then I'm a good candidate for the course as well, because I'm not a coder. I'm an economist. Worked previously in online education, 3D printing, machine learning. So I had a lot to do in areas where a lot of code is being applied, but I usually was on the business development side of things. So Michael, that's why I approached Michael and said, I want to learn some first steps in coding myself. And I'm super happy that you take time today to run us through some steps in coding. But before we really start, I'm actually very curious to get to know you. We are curious to see who else is in the workshop today. So we just invite you to quickly introduce yourself in the chat with your name and your position, and then the job, the company you're working at. So let's give it a few seconds. I start myself. Cool, I see Matthias. Hi, Matthias. Nice to have you here.
Yes. Barbara, good to have you on board. Who else is here? I guess the people have pretty long titles, so they need to, Austria, the country of titles. Co-founder.
Great. We have founders and people from larger organization. That's great. Yeah, I think coding is needed in every organization. Great. Cool, thanks a lot for your introductions. We can still let it running while I'm quickly running you through the agenda of today. If you could go to the slides, Michi.
Yep, sorry.
Cool, yeah. So we start with a very short background about what computers are and some milestones in computing. And I was very curious about this and did a little bit of research that I want to share with you. And then Michael is telling you about what coding actually is, what an algorithm is, and how modern software gets developed. Then we look quickly into different coding, front and back end languages. And then we use a really cool tool called Blockly, open source programming language developed by Google that we want to share with you and do some exercises together. That was really useful for me also to learn a few things, and let's see how you feel about it. It starts very easy and becomes very challenging. So I'm curious to see in the end who can go all the levels up.
Yeah. Some exercises take like 30 seconds and others that take like 7 hours, and it looks basically the same, but it isn't. So let's see how good your logical thinking is today.
Yeah, so just to start off, I started with the question myself and asked myself, what is actually a computer? I didn't know it before, to be honest, what the definition of a computer is. And I did a little bit of research. And what I found is that, in human history, there was a great milestone, basically, when humans went from manipulating physical things, could be a hammer or a wheel, to manipulate information. That's basically the foundation of all computers or computer aids that we know today. There have been previously computational aids like the abacus, which was used in the ancient Near East, in Europe and Asia, which could do basic calculations like addition, multiplication, or even complex ones like calculating square roots. However, these analog things are not really what we know as computers today. So computers today really is the electronic component. And it is an electronic device, very simply, that manipulates information. And the information is in the form of digital data. So data is nothing less than bits of information for some results. Sounds very simple, right? It always performs 4 tasks. It takes input. So input can be from a keyboard, it can come from a mouse, a camera, a touch screen, or even from your voice. And then it stores it. It stores this data in the system and starts processing the information. The information process happens with an algorithm that we will talk about later on it. It puts it back to the storage, starts processing again, and back and forth. So it really does something with the information you provided with. And in the end, it gives output again. And also the output really depends on what kind of computer we talk about. It can be text, it can be photos, videos, games, VR, robot movements. In the end, it's the result of the process data you provided initially. So that's what we understand on the computers. And then I was really curious about what are some milestones in computing. I really dug into this whole topic. I think it's going a bit too far to talk through all of them in crazy detail. I will for sure provide them in the follow-up email with you if you want to know more, but I'm just sharing a few highlights in the last 8 years of internet and computers with you. So basically the first general purpose electronic computer was the ENIAC. Maybe you've seen it before. It was a huge thing, 30 tons, 1 room, and it was the first machine that could basically be reprogrammed to perform more than 1 task. And it was used to calculate artillery trajectories for the US military. A super impressive machine that took so much space. And by today's standard, of course, super primitive calculation powers. The high-level programming language was then the next step that was really important. It could basically turn high-level code into machine code. So you didn't need to know the computer hardware or software any longer in order to work with the machine or give instructions to it. And that was the foundation of the programming languages we know today. A video that I can really recommend and will also send to you later is the mother of all demos. We all know the Apple keynotes from the last few years, but it really roots back to 1968, where Doug Engelbart at Stanford University was basically demonstrating instead of just telling a huge variety of technology in one single presentation. The computer mouse, the video conferencing, word processing, and the ARPANET, which is the foundation of today's internet. A really cool video and extremely visionary. Then microprocessors came, and what's interesting is that little chip that you see on the right side has the same computational power as the whole ENIAC machine, which was 30 tons in 1945. So that already gives you an idea about how quickly computers developed over time in terms of performance. Yeah, and then if we go to the 70s, there was the first commercially successful video game. I think you all know it. It's called Pong. It's a table tennis game, very simple, developed by Atari. And this was also the foundation of the video game industry, which is hugely important today. And also, of course, a computer. WIMP was then the Windows icons, menus, and pointer surface graphical user interface that was used in the 80s. Apple Lisa is the picture, Macintosh is an example, and Microsoft Windows that we all know. In the 90s, there was the development of browsers with Mosaic and Netscape. And then the 2000s that you all know, smartphones, Web 2.0, so websites with user participation. Yeah, I will provide you some links to all of these examples if you want to dig deeper into that. But now, Michael, I really want to know from you now, basically, what the hell is coding?
Yeah, thanks a lot for this overview. It should give you some fun facts you can do at the next cocktail party if you want to be like the smart computer guy. But the question we actually ask ourselves today is what is actually coding, and what is basically the job that all these coders and all the big companies are doing every day, and what does it have to do with the computers we were just talking about before. And before we now want to start like going into a little bit the theory and then also practical examples, I would like to know a little bit more about how much you actually know about coding already before we start, so we get a better feeling if you are like complete beginners or if you know some coding stuff already. So I put together some coding language terms that coders are using every day, which are the following that you should see on your screen now. So that's definitely language. If you ever coded in your life, or if you worked in a coding team, then you should maybe have seen this. So let's see how many of these you already know.
You could choose several ones, obviously. So if you know all of them, you can use all, or maybe you just know one.
Okay, so most people know what a bug is. That's already great. And it's not an animal. Just so you know. Okay, cool. So I've seen it's a little bit a mix. So some terms are kind of known to you and some are not. So I think we have also a good mix. So yeah, I think most of you know a bug, because for sure you have talked to a coder that has tried for hours to fix a bug and to really make the program work again. So if you ever see like a big red screen on a coder's PC, it means like something is broken and the website is down and there is some bug inside the code. So some error or some mistake inside the code that you have to fix to make the website work again. A ticket is like if you are working in a team and you see that something is broken, you would write a ticket. So that means like you write an order for a programmer that the programmer actually should fix something. And then the programmer would take the tickets one by one and fix one after each other. A Boolean is like a term that describes if something is the same as something else in coding language. So you can say if X is bigger than 5, or if X is the same as 5. So that's a Boolean. Decompose means that you break down problems. We're going to talk about this in a few minutes, that you break down always problems into smaller steps that you can solve as a coder. So coding is mostly about solving problems the whole day. So if you're really like a person that loves to solve problems in their personal lives, and you really like love the challenge, then coding is the right thing for you, because every day you have a new challenge and a new problem that you have to solve. And decomposing means to break down this problem into smaller pieces that you can actually solve. Camel case means it's a term that describes how you write a language. So every coding language has a different syntax. So some have to write the letters big, some have to write the letters small. And camel case is like a term that describes if you have to write something big or small in a coding language. And Python itself is a coding language, which you're going to also see later, which is a back-end coding language. So thanks a lot for taking the poll. And I think you still don't know all of it, so that's good. And happy also to now teach us at least the basics today. So let's have a look about what is coding. So coding, basic definition of coding is writing a precise set of instructions a computer or device can process. So we have already heard from the description and the history of Micha, what a computer is. So coding means to write a piece of language or a piece of code that actually these machines that we talked about before can understand and process. So it explains the computer and all of the computers we saw before exactly what it has to do in any given moment. So a computer, once it gets the input, as we said before, like the mouse click or like a button, it needs to exactly know what it has to do in every single moment to give you basically the solution. And that's what a computer is doing. It runs and it solves problem based on a precise set of instruction that you give it. So basically you are writing a code and this code can then talk to the computer. So you're talking to the computer through the code actually. So if you think about what kind of devices or computers are there that you have to talk to, then it's basically everything that is not a physical thing that has no computer chip in it. So everything is a computer, not just a PC or desktop computer you have in front of you, but it's everything. It's a credit card that has to talk and that you have to program that when you actually swipe at the cashier at Hofer or at Billa, that it actually pays. You have the laptop, the computer itself, of course, but you have a washing machine. Like when you click the play or the start button on the washing machine has to know what's happening, right? So you also need to program code for a washing machine. It's also, of course, in the smartphone, but it's in every single electronic device you find in your house, outside, that is run by code in the end, and that needs code to be able to know what it has to do in certain moment. And your job, of course, as a coder, is to write this code and to talk to all these machines through a certain language that the machines can understand, which is then coding languages. And we're going to talk about the different coding languages in a second. So your role is really as a coder to translate the problem in real life into something that a computer can understand. And to give you one other example, what I mean by that and why it's actually much more complicated than you think, is to actually code a computer to go from A to B. So it sounds pretty simple, right? Let's say you want to code a computer or a car that goes from Vienna to Eisenstadt or from Vienna to Vorarlberg. It sounds pretty simple, right? The computer would draw a line and just start and drive there. Well, if it would be that simple, then anybody could write a computer program. But actually, the computer needs to know in every single second what it has to do to come from Vienna to Vorarlberg. And there is definitely some obstacles on the way. So first of all, the computer has no clue what even a car is. So just imagine you want to send the computer from A to B, but you have to explain the computer everything about the car. So you have to explain the computer what a wheel is, how much speed it can go, how long it can, like what are brakes and so on. So you have to explain him everything about the car that you're driving. But you also have to explain to the computer everything that is happening on the way. So he needs to know every street, every traffic light. What if there is a traffic jam on the way? What if the traffic light is red? So you need to tell the computer and explain to the computer everything that could happen on the way and what the computer has to do in every of these moments. So if the car comes to a traffic light that is red, the computer knows, okay, if the traffic light is red, so that's, for example, an if-else statement you would use, then you should stop. If the traffic light is green, you have to go. So you see, just to be able to program a car that goes from A to B, you need to explain the computer all the concepts and everything around this problem. So in the end, you kind of break down again the problem to come from A to B, which sounds quite simple, into smaller problems. One problem is like the map, one problem is the car, one problem is like what could happen on the way. And that's also what you do every day in the coding language or in the coding lab. Taking big problems or the seemingly easy problems and break it down into smaller pieces and explain the computer exactly what it has to do in every moment. Yeah, so again, your job as a coder is to create instruments, so-called programs, or it's also called software, it's a synonym for that, that can be understood by a computer to solve certain problems. So a special thing also about the program is that it's written in a programming language. So there is no program without a programming language behind. And that's also a big difference to, as I said, they're written in specific coding languages. That's also the big difference to an algorithm. So a lot of people have problems understanding what's the difference between writing code and writing an algorithm. So a program, what you write as a coder in a specific coding language, is different from an algorithm because an algorithm is not written in any coding language. What an algorithm is, it consists of a finite number of well-defined individual steps to solve a certain problem. But it's not written in a specific coding language. It can be like, if you have the algorithm for a certain problem, you can put it into any coding language. So it means that algorithms are part of programs, but they're not the same as programs. They are kind of blocks or parts of a program. And to give you maybe a better example, Michael, do you know any easy algorithm that comes to your mind when you see this light bulb on the right side? Did you understand what I was saying before?
Well, when I see this light, well, I was thinking about a case that could be an algorithm. Let's say I come home at night, it's already super dark in my flat, and obviously I don't want it to be dark in my home, otherwise I wouldn't find the way to my kitchen, right? Yep. So I want the room, my entry room, to be filled with light, to be bright. So I enter, I would say the algorithm would then be, I enter my flat. It could be I take the hand, open the door, close the door. I have to go 2 steps left in order to be in front of the switch. I take my hand, I turn on the switch, I turn it down, the light goes on, I take off the hand, and then the task, basically my desired task, is fulfilled, that the room is full of light. Would that be an acceptable algorithm?
That sounds really, really good. So it's exactly what I explained before. An algorithm takes like a problem, like a real life problem, and breaks it down into small steps that a computer can understand. So I think it's a great example. I hope if you have any questions, feel free to ask in the chat if you're not sure what an algorithm is. Because now actually we would like you to write your first algorithm yourself now. So already take a piece of paper and a pencil, or yeah, your favorite pencil. And we ask you to now take like 2 minutes to write an algorithm how to make a cup of tea. So it sounds pretty simple, how to make a cup of tea, but we want you to break down this real life problem into something that a computer can understand and into an algorithm. So you now have like 2-3 minutes time to write down an algorithm, and then it would be great if some of you could share, if one or two could share like their solution to that.
So I have to think of all the small sub steps, right, to make a cup of tea.
Exactly. So we give you, as I said, 2 minutes, 3 minutes. I hope you by now have all a piece of paper and a pencil. Okay, 26, so we have time until 28. And maybe you can quickly write in the chat if you're ready, that we know how much time you would need. Or if you think you're ready with a basic algorithm.
well, you could break it down to 20 sub-steps. Maybe we can say 5, 6 major steps in order to make the tea, right?
Yeah. That's also something we always try to simplify things in coding, not overcomplicate it, because otherwise there is too much code that slows down the program. So you should always find the simplest and fastest solution.
So whoever has already written down their algorithms, share it in, you can let us know in the chat. Maybe someone could also share their solution.
Yeah, you don't, if you're ready and post in the chat, doesn't mean that you have to do it. Don't be shy to say you're ready.
I'm sure that Gaura, for example.
Laura is done. Perfect.
Ah, cool.
It's a star for you.
So Laura, I'm not sure if you want to share it with us, or
maybe let's wait for some more to be ready.
Perfect.
Daniel is ready. Okay, let's wait for some more.
Alexander as well. Silke as well. Great. So yeah, if who would be willing to share the results quickly with us and run us through?
There's no wrong answer in coding.
Well,
there's always a better answer, but there's no wrong answer. So. Okay, anyone wants to share?
No one wants to expose themselves. Barbara, I'm sure you can break the ice. We want to see your solution.
Of course I can. So my steps would be: take the tea boiler, open the top of it, enter the water, put it on the boiling station, take out a cup of the tea out of the, take out a cup out of the cupboard, and then take out the tea box, take out the tea bag, put it into the cup, take the water boiler can from the station and pour the boiled water into the cup and wait.
Nice. Good job. Normally we would applaud in the room, but this is virtual. Really hard.
You.
Thanks a lot for sharing. Anyone else wants to share? I'm sure there's also another solution, so don't worry. Come on, guys. That's already great. One thing I would add as a coder, and to the second one actually, because in the first one it was quite easy. You put it on the cooker, on the heater, and at one point it boils and it's done. But I guess in the second example, where you put the water on the stove, you would actually normally add an if-else statement. So basically, you would let it run until the water heats up over 90 degrees, because otherwise the computer doesn't really know when it should stop. It will just heat the water until it's evaporated, basically. So normally you would have like a loop or an if-else statement. I'm going to explain later. Like a loop that says heat the water until the water is above 90 degrees, and then it should stop. And then you know you can put it into the cup. That would be just something that I would add to this algorithm. But really nice, and I think you hopefully got what an algorithm is. And again, the difference to a program is that an algorithm is just kind of the separation of a problem into steps, while it's not written in a specific coding language. It's not a program per se, but it's part of a program, and it can be used for different coding languages. Okay, so I think we got the algorithm covered. So let's come to the next part, which is actually modern software development. So if it would be as simple to just write an algorithm and that's it basically, and you have the problem solved, then it would be great. And like the coders would probably work for 1 week and they have a completely new product. But as all of you know, especially today, customers or also ourselves expect much more than an algorithm. Like if you want to buy, let's say, just a simple calculator, or you have a calculator app, you don't just want to see like a empty screen where you put like 2 + 2 and it gives out it like returns 4. But you want to have a nice design, you want to have like nice colors, you want to have security, that nobody steals your data. So coding on one hand became in the last years much easier because there's much more tools, but at the same time a coder needs to know a lot of different concepts to be able to develop a program that is actually in the end used by customers and that solves really problem in the real life. So programs still need algorithms that, like we just did, basically breaking down problems into small steps, but they also need great user experience. So meaning like the user needs to have a nice flow. Let's say in Spotify, you don't just want to put in one song and you get it as a result, but you also want to have maybe songs that fit to this one. You want to have like nice lists with nice colors. It should like look really nice and have a nice structure. Also, coders need stuff for the design. They need stuff for testing it before you actually launch the product. So you also need to know this concept. You need to know data analytics. So how, let's say after 1 month you have your app on the market and you want to know how many users actually use the different features of your app. You want to know this, and you need to ask the database how many users are active each day, or how long do they spend on each page. So you also need to know the concept of how to integrate a database into your apps and how to, in the end, get data from this database to understand what's really happening. And then also as big topic, security, like you want to have protected data, and someone that is using your app doesn't want that the data could be stolen. So as you see, as a coder, you have to have an overview of a lot of different concepts. And that also means that not every coder can know everything, right? So I code for some months, but I know parts of it, but if I would like, for example, to work on the security topic, I would need to find another coder that is really like a deep expert in security, because I'm more like now an expert, let's say, in user experience and design. So, and how modern software development is distributed is by different languages. And I'm going to explain a little bit the overview of what kind of languages there are and what kind of coders or types of coders there are in the market. So again, as a coder, I need to understand the basics of a variety of different concepts. And I also will need to work with other coders that know other languages and have other expertise. But I will also need to be able to work with designers that make the app look nice in the end, that need to add the colors and come up with the logo. And in the end, I will also work with business people that bring this app to the market and do all the marketing and sales. So it's actually it's not a job where you sit the whole day in a dark room in front of your computer and just code line by line and line by line, but it's also a lot of interaction with other coders, and in the end also with business people that in the end, bring this app to the users. Yeah, so to explain a little bit, what is the difference, what are the different coder types or roles in coding? There is the best way to distribute it is between front-end versus back-end languages. And I guess some of you have heard already of these terms. What does it mean? Front end, I mean, it's already in the name, but it means that everything that the user sees on an app or a website is considered as front end. So that's the front end to the customer. Everything that he interacts with, every button he clicks, everything that he sees on the website is front end. And back end is everything that happens in the background. So once you click something, the back end takes this input, as we said before, processes it, and does some calculations and gives you back an output. And it can be also it's similar to having the iceberg on the right side, where the front end is like what the customer sees, and the back end, which is a lot of times much bigger, which considers like server and calculations. That's all considered the back end, which is not seen by the user. To give you a practical example, I've taken Airbnb. I guess all of you hopefully know this platform. And it's a very modern startup that has been very highly successful, especially because of the front end. So most of you know that Airbnb actually had a big competitor before, which was Craigslist, and that had the same offering as Airbnb with all the different hotels and accommodations, but it just looked like a mess. So by changing the front end and making it look very nice, Airbnb actually won in this market and is now the biggest player in this market. So let's have a look at the website. You see already a lot of different things. So I typed in, I want to go to Paris for 2 days with 2 guests. And you see that on the left side, I have, as we call them in coding, we have so-called cards. That's like a splitted area of information that belongs together. So on the left side, you see the picture, on the right side, the information to the picture, and that altogether is called a card. So you see on the left side, different cards of different apartments. You see on top all the different filtering options and buttons, and on the right, you see a map. So if you think about front end, what can we see on this page? So first of all, we see the page has a certain structure. You start with like the headline on top, and then you have the buttons, and then you have the cards, and then you have the map on the right. So this, first of all, every page has a certain structure, which is, as I'm going to explain in a second, one coding language. And then the second part is the design. So you see that, for example, here we have a special font that is bigger. We have like another font that is smaller on top. And we have like pictures that have rounded borders. And like everything, there's icons. So everything has certain colors. So that's basically the second part of the front end, which is the design. And then the third part of the front end is like buttons that you can interact with. If you click on price, which I can't do now, something would pop up and it would show you the different options to filter the price. So if we summarize it, you actually see that we have the structure on the left, which is the cards, and the map on the right. We have the design of the colors and shapes and size and fonts, and we have so-called mouse overs and filtering buttons that is like animation. So all of the three together belong to the front end. So everything that the user can touch, can see, everything that pops up, that's all front end. It's all like what is to the front of the user. If you think about the backend, let's have a look at the page. Where do you see the backend? So of course, you don't really see all the calculations that are happening in the back. But if you take a look at, for example, the information that is provided here, right? So we typed in Paris, and we typed in 10th of July to 12th of July. So what happened before we came to this page is actually that this data was sent to the backend server, and the backend server then said, okay, where in Paris do have apartments that are free from the 10th to 12th of July? And it calculated basically that these are the apartments that are free, and then it even ranked them by the order, by the rating, and it probably even took into account more factors of like your past searches, and then it gave you exactly these cards, right? And not another card that is maybe a rating of 3.8 or that is not in Paris. So everything that's happening in the background that you don't really see here, but you can kind of see it with the information that is provided, is in the backend. Also here on the right side, you see, for example, the calculation. The program knows one night costs 105, but it has to calculate before it shows up. It has to calculate that you searched for 2 nights. So it has to calculate that the total is 210. So again, the backend that we can see is the price calculation, the availability information, so you know that these are available. And then here on the right side, you also see that the backend has calculated where these dots should be and like where it should be displayed. Again, the front end displays it and says like, okay, here on the right side on the map, you see like nice bubbles, they have this color, they have this font, and the backend, however, says where should these dots be and like what should be shown to the user depending on the search. So I hope this gave you kind of a first differentiation between front end and back end. Are there any questions to that part? Because I think that's super important. Is there any questions to it? Is there any, does anyone have any concerns about this front end versus back end languages?
I actually have one. So now what we saw is it's a website in a browser. Is there also the concept of front end and back end on smartphones and on other computers?
It's exactly the same. Like on an app that you download, let's say Uber or Spotify, it's exactly the same. It's just in the end, as a programmer, you have different sizes of screens. Like you have a laptop, you have an iPad, and you have a mobile phone. And in the end, what you have to do is you have to customize the design. You maybe put the map on the bottom when it's a smartphone and the cards on top. And that's something it's called making an app responsive. So it doesn't matter how the screen moves, it still looks nice. And that's also the job of a front-end designer, to actually make sure that the app looks good on a desktop, but also good on an iPad and good on a mobile app. Okay, if there are no examples, so what's the important thing about front end versus back end? So first of all, it allows, as I said, the distribution of tasks. So actually, if we come back to that page, a front end designer can design everything and work completely independently from a back end designer. So the front end designer can make this like picture cards and can make the text, and he just believes that the information that should be inserted here will anyways come from the backend. So he doesn't really care about the data in the back. He just thinks about how it should look like, and that the picture should be on the left and the text should be on the right, and here should be a button and so on. And he just expects that the information comes from the backend. And on the other side, the backend guy, he doesn't care about the front end. He just has to care about that the algorithms and that the formulas have to work, and that in the end he sends the right information to the front-end guy. What the front-end guy does with this information, how it displays it, it's not part of the backend. So when you want to start a coding career, I think it's also a little bit about and you don't want to become so-called full stack developer that does everything, does front-end and backend. You have to think about what is it that you like. Do you like designing things and think about the user flow and how it looks? Then you rather want to become a front-end developer and learn certain front-end languages. And if you say, no, I actually love databases and like calculations and thinking about complex algorithms, then maybe the back-end career and learning back-end languages is the right for you. So it's very separated, and only in very small companies like startups where you have maybe only 2 employees, there it's really important that you know everything, and then you are a so-called full stack developer, which means maybe one day you work on the front end, the next day you work on the back end, and so on, and you switch between the roles, which is not what I would recommend, because it just makes everything smaller and you cannot specialize. That's the second part that I wanted to mention, why it's important. You can specialize actually. So as I said before, it's very hard to know everything really well and do everything super fast. So by specializing either on the front end or on the back end, you can become much better in what you do and be much faster in designing or be much faster in making algorithms, and not trying to do everything and being kind of, having a high level overview, but not really knowing something into deep. Okay, so I think we talked a lot. The last theoretical concept I want to give you before we actually jump into exercises is that I explain you a little bit what are different front-end languages that you should at least have heard about. So the first one that most of you should have heard about is HTML. HTML was one of the first coding languages, and it's still widely used. It's definitely not outdated. HTML cares about the structure of the page. I'm going to show you in a second how a page would look like with just HTML, which is quite exciting. But basically it thinks about, okay, the headline is on top, and then the paragraph, and then the pictures, and so on. The CSS, which is a second language, is all about the design. So it takes the structure and makes it nicer by adding colors and shapes and sizes and so on. And JavaScript is all about animations. So if you think about buttons that you click and something pops up, that's always JavaScript. Or, which is a new part of JavaScript, is React. So it's like an easier program for JavaScript. So if you want to go into front-end development and you want to maybe program your first website, you should first start with learning HTML, which is the structure of a page, then CSS, and then JavaScript. Or you learn all the 3 at the same time. But yeah, that's pretty tough at the beginning. So I would recommend you to start with JavaScript. And that's...
We have a question here. The people, like the front-end developers, a classic front-end developer, would they know all of these 3 languages, or would they just work on the structure and one more on the design? Or do they kind of have merged roles?
It depends how large the team is, of course. If you are working in a small team, you normally know everything. And generally, I think most front-end developers know all the 3, HTML, CSS, and JavaScript. But it could be that you work in a very large team and you distribute the tasks. Then maybe one works on the CSS and one works more on the JavaScript. But that could be. But generally, in smaller teams, you would have one that knows everything, because it's very strongly connected. To give you a practical example, again, what is front-end and how you can differentiate the languages. You see here Booking.com, again, a page I think every one of you knows. If you look at the page, again, what do you see? You see like a navigation bar on top, you see like a search field, and you see like all the hotels. So the structure of this page is done with, or is coded, programmed by HTML. All these colors and like rounded shapes and how big the sizes are and so on, this is all CSS. So CSS takes the plain text and says like it should be this size, this font, and so on. And JavaScript, it's like everything that's happening when you click on something and it pops up and goes back without like the page reloading. So you see on top the URL, like the website link, it's not changing. Everything that is happening with JavaScript, and it's just opening and closing without reloading the page. So everything that is animations on the page, when you click on something and it pops up, that's all JavaScript. And to give you an even better example, I want to show you how you can actually manipulate any website on this earth by clicking. If you go on a Google Chrome, you can click right click and you go to inspect. And what you see and what will come up is all the HTML and CSS code of this page. So you see on the left side how this page is basically coded. What's the HTML behind every single element? And now I want to show you something pretty cool, which is actually deleting, which is in the head, you have normally all the intelligence, and in the body you have the content. And in the head, you also have the CSS, which stands for the styling. And now if we delete all the, which we can do, if we delete the CSS from this page by just clicking back, this is all the style sheets, basically all the CSS. You see what's happening on the right? All the styling of this page is completely gone. Everything that just stays is HTML. You see, it's just the structure of the page. Boom, everything is gone. Oh my God, my page is broken. Yeah, this would happen if you write a wrong comma somewhere and the CSS breaks. Then what you have left is just the HTML of the page. Pretty crazy, right? So no worries, I didn't break the page. This is something that you can do in your browser, and you can manipulate things in your browser. Let's go back to booking.com and see if it's still there. Oh, it's still there. We didn't break it. Great. No lawyers coming for me. So what you can also do here is you can choose this arrow on the left, and you can click on any element on this page. Or it's giving me a headache. You can click on this element and you see what it is basically. You see that it's an H1, so a headline 1, finden Sie die Angebote. And you can click on here and you can click on element style on the left side. And you can, for example, say color red. And boom, the color is red. So you can even play around in your own browser to change elements of a website in your browser. So you're not really tackling the booking.com page, but you're just doing this in your browser, and you can play around here. You can, for example, say, I also want to change the font size, so the size of the text to 64 pixels. Boom, and suddenly it's getting huge. So that's basically the job that a CSS developer is doing the whole day. He looks at the website and he plays around in this inspect thing and makes it look nicer and nicer. And when he likes it, he just copies the code from here and puts it into the program. So that's something you can definitely play around if you just want to try a little bit of CSS, just grabbing with this selector on top, grabbing any element, and then just writing some stuff. So font size, you can write the color, you can maybe make some border around it. Yeah, all of the different things. So I hope this gave a little bit of insight into the front-end development and how these three languages work together: the HTML for the structure, the CSS for the colors, and the JavaScript for all the animations. Michael, do you get the concept?
That was a lot to digest. No, but thanks. It's for also making it very visual. I like the red. It's like the red title now really makes me want to book holidays immediately. No, it's cool. Thanks for explaining. For me, it's interesting. I've actually used this inspect function before without knowing what it means to just find the root of a picture. Sometimes there is a picture with text on it, and I just use the inspect function to download a picture. So it's good to know that you can manipulate this code.
Cool. Okay, let's go back. Just quickly, last thing I promised before we go into exercises is the backend languages. So we've tackled the front-end languages, which is HTML, CSS, and JavaScript. And now about the backend languages. We have backend languages that are all, they don't have like in the front end like the different functions, and it's not like you use Python together with Java or together with Ruby and they all have different kind of functions, but they are all very different languages that do the same thing. So you can either program an app in Python or in Ruby or in PHP. You cannot mix the languages. So you have to choose one of these languages for your business, for your startup, for your company. And the differences are actually not so big. So generally with Python, Ruby, and PHP, you can program mostly any app in the back. So again, the coding languages per se are about the server, about like calculations, about algorithms, so everything that is happening in the back, and they can all do it. There is very small differences between them. For example, if you want to start into coding and you have never heard about backend, Python, for example, is a very new language and also very easy to learn. So it's very explicit. So everything that is happening, you write it in one line. Ruby, for example, is especially a good language for web development because it has a lot of pre-defined apps. So you can, like in App Store, you can download an app for Ruby and that you have a financial payment service. You can download an app and you have a chat function. You can download an app and you have a, a review system. So Ruby has a lot of like predefined apps that you can just install and it basically works. The downside of it is, however, that in Ruby, you don't understand everything that is happening. So let's say your financial services tool to pay is like broken. It's so hard in Ruby to understand where the error, where the bug is coming from. And then PHP is more a language for very complex technical products, like Siemens is using it. Ruby, for example, Airbnb is using it. Also, Apple is using it, and Python, also Google is using it. So every of the languages has its existence and has a lot of companies, really big companies that are using it. It's just a lot of times like small differences, and it depends a little bit on what kind of app you want to develop and what kind of language you want to learn. Again, if you want to start into it, the easiest to learn is Python, because it's very simple and everything that is happening is in one line and you can easily find any error. But Ruby maybe gives you a faster framework to develop first prototypes and apps with functions like payment system and so on, because they're already existing parts. And the second part to backend is always database language. So on one hand, you need like these algorithms that calculate something, but on the other hand, you also need to have a database language that stores all the data that is coming through the apps in some variables. So if you sign up as a user, your user login data needs to be saved somewhere. If you upload a picture of you on Facebook, this data needs to be stored with your profile. So everything that is happening on the app and that you want to track needs to be stored somewhere. You want to know how many users you have, you want to know the emails of them, and so on. Everything needs to be stored in a database. And normally what is used today and what is the most popular is SQL. Some of you have for sure heard of it, or the kind of the child of SQL, which is PostgreSQL, which offers just a little bit more functions and is mostly used today. And these are really just languages that store data, and you can also ask the database for data. So you can say like, hey, give me every user with a picture, or give me every user that doesn't have a picture, or give me every user that has spent more than 10 hours on my app. And so the backend language like Python, Ruby, Java, and PHP, they are all kind of similar. They can all do basically everything. It's just like a little differences depending on the language. And the database languages are SQL and PostgreSQL that are more for storing data and for getting more data about your customers and so on. So on the right side, you see some of the code. I'm not going into depth about that, but I think we should let's have a look at some examples of how you can code, right, Michael?
Absolutely. Maybe there are some open questions. I already asked in the chat, are there some questions with regard to front end, back end, or is the difference clear? Or about the coding languages? If so, please ask them in the chat. And let's see. Oh, okay, Stephanie, great stuff. Then we can also go more towards examples and exercises. And whilst doing the exercises and examples, you can always ask Michi He shouldn't go home without any critical questions today, so we want to test his knowledge.
Okay, so let's see if there are no questions right now. Let's see some examples of something that has been coded and how it has been coded. So the first one you see on the right side, you see a beautiful sun, right? You would be thinking, okay, a small child drew this in the I don't know, first class of kindergarten. But actually, a computer can also draw this, and we're going to show you now how this would be done by a computer. So let's see on the right side. You see, this is a as we said before, it's Blockly. It's a visual programming tool that allows you to train your logical thinking and to start solving, as we said, problems and break it down into smaller pieces, and yeah, really allows you to play around with coding in a visual way. So you see on the left side, you have like all these building blocks, and then you can move it to the right, and then the right, you basically build your program. And let's see a little bit what's happening if we run this program now. Ooh. You see it runs through the right side of the code and just does basically what you coded before. So it repeats 360 times. It's coloring something in blue, and it's always moving forward, then moving backward, and then turning one to the right. So it just, you see 360 times coloring basically the window. And if we go a little faster, ooh, then you see that actually it's becoming a sky. Wow. You see a computer drawing here. This is pretty special. And let's see what's happening now. So now you see that the computer is 360 times coloring yellow. It moves 50 forward, so not the whole one, but not the whole 1000 till the end, but only 50. And again, it's going forward, back, and once to the right. So if we do it faster, it becomes a beautiful sun. And now I have to go slower because otherwise it's over. So what it's doing now, it's just repeating 10 times, and it's moving up, moving down, moving forward and backward. And then it's kind of changing the direction. And it's coloring the sun. Boom. So you have seen basically how you break down a large problem of drawing a sky and the sun into coding language. So by repeating 360 times this movement and always going one to the right, you can actually draw a blue sky, and you can draw a sun, and you can draw all these other pieces that make it look like a sun. And now we actually would like to, I think, go into exercises, right? Where you can actually try it out yourself.
Yes, if we want, we can do the Blockly exercise, which I think is really good. So maybe we can do the first one together, and then I will send you the link, and you can all try it out yourself. There was also a question, by the way, from Stephanie Ogulin. Yes, the number was referring to the area, to the pixels, and I think the whole square was 1,000 pixels. Okay. And basically the pen had to be instructed how far it has to move forward and backward, and how much to move in each angle. But here is an even simpler example. Michael, we can change the display on the top right. Yes, you can go. Maybe that one is better. Yes. Okay. So here we can do that together. I'll try to solve it, and then we give you a task that you can solve yourself. So basically here the goal is to have this small, that guy here that needs to go to the final location, which is indicated by red. And I have different things to do. I can either move forward, I can turn left, or I can turn right. So let's say, Michael, I have to give now the instructions. I would say I move forward, I go left, and then right. This would be like the set of code, right? And let's see if it's correct.
That's, yeah, on the left you can run the program, so let's see. Ooh, what's happening? It's not there. I think, Mike, I think you forgot some parts.
Okay, it just goes forward, it turns left and right. Okay, it needs to walk more. So I guess it's then move forward, turn left, move forward again, turn right, and move forward again.
Oops, that was wrong. Turn right, move forward. Okay, let's see if that worked. Woo! Nice.
Perfect.
Great job.
So that, and here you can see the code. So okay, that's JavaScript lines then.
Exactly.
Okay. Now, I hope the concept is clear to everyone. Now we want to give you a bit more difficult exercise. I'm going to post the link and let's see if you can solve it yourself. 1 second. Just have to make sure that the solution is not already. Okay, I go to level 4. I think you can do level 4, right?
Yeah.
I hope you're all there to do level 4. Okay, this is the link, level 4. And let's see, whoever has solved it can also share the results. So it's directly in the browser, you can open it and you can change the, what's it called? The skin and the display on the top right, if you can either choose the astronaut or the map. I hope everyone could open it.
See how good your coding brains are.
Oh, okay. I see that they already see the solution. I hope that's not the case for everyone. If so, then please delete it. Maybe Michael, can you post it so that people don't see the solution?
Yep, sure.
Or you can go to quiz number 5 and post it.
Yep. Quiz number 5. Okay. 1 second.
Or 4 is actually nice, but it seems that on my link there was already a solution in it.
Okay. So, how do I come here to the chat? It's a little bit of pain. Oh, here. Got it. So
Perfect.
That should be hopefully without any solution.
So if someone managed to solve it, we're happy to hear your solution. Daniel, cool. Move forward. Good. Verena also. Cool. So maybe Michi, you can simultaneously do the solution here for everyone.
Yeah, sure. So
what was the thing here with this repeat until? What's the trick about this, Michael?
Basically, it's a loop, as I said before. Like you want the program to loop certain actions and do certain actions again and again until a certain condition is reached. So as I said before, like an example could be, yeah, in this case, you want to reach a certain target and it should like drive straight until you hit a certain target. Or I don't know, an example I came up with yesterday was if you have a Pokemon, let's say a Glumanda, which is the first stage of the fire Pokemon, you have at the beginning you have 0 points of experience in the Pokemon game, but then you start fighting against other Pokemons and every time you win, you get like 50 points. And then while you have below 1000 points, you stay a Glumanda, but once you go above 1000 points, then you go to the next level and you transform into Glutox. No, how is the second one? Oh, damn. Or you can transform after that into a Glurak. I don't know. So basically it's a loop. While you have below 1000 points, you stay whatever level 0. And then you gain more and more points, and above a certain point you transform to a new level. That would be, for example, a loop that the computer has. installed that you have to fight against other Pokemon until you reach the next level. But let's check about this. So we want to repeat this loop. And what do we want to do? First, we want to move forward, right? Then we are here, we want to move left. Ooh. Then we again want to move forward. And then we want to turn right. And then we are here, and then the whole thing begins again. So let's see if that works. Woo. Nice.
Cool. And it says repeat until the red one, so it only finishes when it's arrived there.
Okay, cool. I hope all of you got that.
So let's go a bit to a more advanced one, and let's see.
Level 6.
Oh, good. Maybe you can even go to, yeah, level 6. Okay, delete it. So who would like to solve level 6 together with us? Daniel, maybe?
So let's...
Who dares? You can also write in the chat. You don't have to speak up. But Daniel, how would you start?
What do you think we have to do here?
And then, if pass to left, then what should it do?
Then turn left, maybe.
Mm-hmm.
Let's see what's happening now. It looks if there is something to the left. Okay, now there's something to the left. Whoa. It looks. Yeah, we turn left. Yay. Nice. Perfect.
Cool. Oliver also solved it. Congrats. There are some hidden champions in the class. Annabelle, I'm sure she's also good at this. So let's see, next level. Who is the daredevil for level 8 or 7? Which one do you want to start, Michi?
Who has some ideas here, yeah?
Yes, let's level 7.
Okay,
here we have several. What's the thing here? We have several. You can either go left or right. Who wants to discuss this one? Annabelle?
Okay, first we have to go straight, right? So at one point we definitely need to move forward. So then
at one point we have to turn right.
If we have a path to the right, and we should be able to turn to the right, right? So somehow we need to change that to the right. So, but I guess maybe we should first move all the time forward. We move forward, then we come to this crossing, we want to go to the right. And if we want to come to this crossing, we want again to go to the right. And to this crossing, we again want to go to the right. So every time there's a possibility.
Every time you can go right, you need to go right. So I would take the if condition, if path right, do turn right.
Yeah.
But then also go forward. You cannot just turn right. You also need to turn right and then immediately go forward. Otherwise, you're stuck.
Well, if you...
Ah, no, it's move forward already in the condition before. You can try it and run the program.
Let's see what's happening. Maybe I'm wrong.
No, I think you're right.
Oh. Ooh. Yay!
Cool.
So as you see,
okay.
we could also put and move forward here.
Shall we do a last one?
The next one?
Yeah, I think we can do one more, and then also leave some time for questions, and let's see. But
okay, let's see what we can do here. So we have to move forward, but we sometimes have to turn to the left and then also turn to the right. So there's definitely somewhere a turn to the left involved and a turn to the right involved. So we move forward. Does anyone have an idea what we have to do?
I guess we need to reuse the green one again, because it reduces.
We definitely have to repeat moving forward, otherwise we just stop at one point. What we can do is like
iteration increment from Annabelle.
What do you say? Iteration increment.
What do you mean by that? Okay, that's the repeat until, right?
Okay, we use that, so we move forward. So every time we have something that goes to the left, we also want to go to the left, right? So here, at least here, let's see what's happening. Oh, it turned to the right. That's wrong. Let's see again what's happening if we turn. Okay. So it manages to go to left. Okay.
Now it's stuck because it doesn't know that it needs to go right.
Yep, that's true. So what we can
What
do
if we would put another if?
yeah.
What if path ahead
Is
is
right.
yes? Then
Turn right.
yeah.
Okay, let's see what's happening now.
Ah, Verena. Wow. The silent champions and Oliver. That's also how I imagine the real coders. They're not like speaking up like me and always talk, but they're more in the background and solve the problems silently. So Verena and Oliver, you're the true coders, and I think your solution is right.
Yeah, you see,
cool.
It's pretty much like coding live daily. It's like you have a problem to solve. You start trying something. You press play, which means you try to load the page. You try to load the website and it's broken. So you try something else, website is broken. You try something else, website is broken. You try something else, boom, it works, but everything looks weird. So at least you made it work, but some buttons are not where they should be. And then you at least know, okay, this part is working, but the buttons are maybe not at the right place. And that's how you basically start digging into it and solving it and coming to the next step. And at one point you can, as we did, do quite complex stuff. And actually, I have a little challenge for you because we don't have so much time. But if you could, you should try level 10 because it's really, really hard.
Can we please go quickly to number 10?
We can check
just
it.
I couldn't solve it myself.
It's pretty hard, and we cannot do it in the next 5 minutes. But you see, it has a lot of different ways to go, and you have to turn left here, turn left or right here. Here you can turn left. Here you can turn right and left. So it brings definitely some issues because here you want to go right, although you can go left and right, and here you want to go left, although you can go left and right. So if you really want to train your brains for solving algorithms and for solving coding issues, then definitely try out this one later. And yeah, don't worry. It took us also quite long to work it out. So
did you solve it?
I'm about to solve it.
Okay. So what would be the challenge? Let's make it a challenge. The first one to solve it gets a coffee and a sweet in our office in Talent Garden. You can come by and you're invited for coffee and dessert with us if you hopefully live near Vienna.
Yeah, so if you solve it, just send us a screenshot of the blocks and then you can come by and we provide you a snack and coffee. We can discuss more of these fun problems here. I mean, this is like, this is a visual programming tool, right? What it does, it trains your logical thinking. It's not the same as writing code in a backend language, because in the backend language, you basically need to translate moving forward into code and turning left into code and so on. And this is more like a computer game and not really like apps or something that where you say, okay, if you click on that, it should give you a database or it should give you this hotels, for example. Mm-hmm. But it's definitely great to as I said, to train your coding thinking and to start breaking down big problems, like coming from here to the end into smaller chunks of steps and just practicing yeah, to go one step after each time. And as we have still maybe 5 minutes left, and we went faster than I expected, I want to show as a last point that I prepared how actually coding teams are working today and what is like modern software development. As I said already before, as a coder, you will probably not work alone, but you have a team of coders. So you have normally front-end and back-end developers, as you see on the left, that are doing, as I said, the HTML, CSS, and JavaScript and all the functions. And you have a back-end team that does all the calculations and the algorithms. And as we saw before, today the customers are really also expecting a nice design and the user flow. So normally you also have a so-called UX designer on your team. That is a user experience designer. He just thinks about the user and just improves the flow of the user every day and works together with the coders to make it happen. So he thinks more about the whole flow of the app and is not really coding like the single pages. And then in bigger teams, you also then have a product owner, which is like a person that is in charge of managing this whole team and also thinking about the strategy of the company and aligning the product development with like what the board or what the management wants as a long-term strategy. And he really thinks about developing products that are fitting to the customer needs, while then the UX designer takes this like high-level kind of wishes of the product owner to transform it into a user flow that is the best for the user. And how these teams are working normally is in so-called sprints. So they are not like meeting every day and discussing everything that they code, but normally they have a first meeting where they discuss, okay, what do we want to program in the next 2-3 weeks, and what should be the new features for our users. And then they have 2 weeks so-called sprints where they work every day on these new features and functions. And at the end, maybe you see it here better on the right side. So you have a product backlog. So it's basically everything you want to develop as a team. And then you say, okay, from all these features that we have on our list, for the next sprint, we want to develop these 2-3 features. For example, we want to develop like the payment system, or we want to develop a chat function. And then this comes into the sprint, and in 1 and 2 weeks, the whole team works on these 1 and 2 features, makes them really perfect. And then it becomes a shippable product, which means you push it to the market. And in the end, the customers can use these new features. And that should be like, you do it in very fast and iterative cycles in very short period of time, that you can also push new features to the market very fast. So it doesn't take half a year until a startup or a company brings out like a new product, but you can push every 2 weeks something new and then directly test it with some users. So that's really how coders are working today, which means that they are mostly kind of working on their own during these 2 weeks, but then you have planning sessions where you talk together what you want to develop. And in the end, you kind of sit together again and think about what did you do in the last 2 weeks, how did it work, how we can improve it, and then you start the next cycle. And this is kind of strict, so you really want to do 8 hours a day developing these features and discussing them also when you're done with the feature, and also have time for debugging, which means like taking away all the errors that are still in the app and making sure it works. We say on production, so production means that the real user use it, and then you have a shippable product in the end. And how you do this normally is think about the user. So what does the user want as the next feature? What is the biggest problem of the user? And you define the next feature, and then you transform it into concrete steps that the coder have to take and do it in the sprint. And the best way would be in the end to think always about the end user that gets the shippable product and develop develop programs that solve these problems of the users. I hope this kind of gave a good first. Let's think maybe to give you a last example. If you are a startup and you want to open a web shop, let's say you want to sell products, whatever. You want to sell computer mouses that are super ergonomical. You always should start thinking about what does the user want. So what is the basic feature a user wants that you should develop first? And the basic feature of a web shop is that the user can look for a product and can pay a product. Without that, you don't need a web shop. So that would be the first thing you develop as a team. You sit down and say, our product backlog is that we want to develop this kind of features. And in this first sprint, we want to develop the payment system and the maybe that the products are there in the database. And then you will also split up between front end and back end. So the back end thinks about the calculations, and the front end thinks about how does the design have to look like. Once you're done with that, then you can do the next usage. What is the next important thing? Maybe a review system. Then you work on this in the next sprint. If you're done with that, what's the next important thing? I don't know, that you can, what is next? That you have the security on your, maybe on your product, that you can ship it back if it's broken, something like that. So you basically go one step ahead, starting with the most important user stories and user problems to less and less important ones. That's, I think, the last one I wanted to share, how the teams are working today.
Cool, Michael. Thank you so much. It was a long journey and a lot of insights today, for me at least. I learned a lot, and it was cool to have your expertise and knowledge, and also to solve some exercises together. I'm very curious to hear the feedback of you guys who participated. You can either just give us a quick feedback now, and also if there would be a follow-up session, what kind of content you would like to learn. We thought about doing maybe another one about coding in a few weeks. What kind of topics would you be interested in deep diving? And if you don't want to do this publicly or like via video, there is also the feedback form. There you go, where I'm super happy to hear what was interesting and especially which topics would you be interested in going deeper for a future session. Yes. But for that, I can see from the chat, everyone enjoyed the exercises.
Yeah, maybe if there are no more questions, how would you start into coding? Maybe to give you a last kind of recommendation from my side. So first of all, as I said, you should think about, do you want to become front end or back end? What's like the thing you like more? Is it more like the design, or is it more like the back end, the complicated algorithms that you like, or the database behind it? And then you should start, and if you want to start with the front end, you definitely should learn HTML and CSS first, because this is the structure of every page. And if you don't have a structure, you cannot make animations and so on. And concerning the backend, if you want to start with an easy language, learn Python. There is a lot of Udemy and Udacity courses to get started. Also, I can recommend Codecademy, because there you don't just have videos where you learn it, but you can directly have a lot of exercises. And then if you really want to learn it from scratch and do it in a fast way, there is also several boot camps in Europe where you have like I did with Le Wagon, like 2 months, really intense training every day for 10 hours. And you can do this, for example, with Bildungskarenz, that you take off for 2-3 months and really do that and do it full time. And there is definitely, you make the fastest progress, and you can directly apply also your knowledge in practical projects there. And yeah, so I think that's a good way to start into it. And also these broccoli exercises to train your logical thinking. And yeah, I think that's the best way to get into it.
Cool. And what I just mentioned in the chat, that the websites that Michi was mentioned before, as well as the slides and some other links that we think could be useful for you, will be all sent in the follow-up email. If you haven't signed up, you can shoot me an email at any time. And yes, I'm happy to feedbacks in the form. And otherwise, I would say that's it for today. Thank you all for joining and doing this 1.5 hours with us. It was really great, and also cool to have so much feedback today and engagement. Have all a good evening, and thank you, Michi.
Thank you, Micha.
Bye-bye.
Thanks. Ciao, guys.